Welcome to our third episode of AI Today. We are once again joined by Cornell Tech professor Karan Girotra for an update on what is going on with AI, tech, and of course, business transformation. I should mention that Professor Girotra is a faculty author of two online certificate programs here at Cornell, the Generative AI for Productivity and the Generative AI for Business Transformation certificate. So I recommend you check out links to those programs in the chat if you are eager for education in this space. Great to see you again, Karan. How are you doing?
Very good. Great to be back on the show.
Great to have you. And of course, also joining us is Professor Alexander Sasha Rush, who joins us from Cornell Tech in New York City to discuss AI. And for today's episode, open source models. Welcome, Sasha.
Thanks for having me, Chris.
Oh, it's great. Viewers, before I pass the mic over to the guys, a couple notes, and I think you should check out our two previous episodes of AI Today. We shot one in May, and I think we shot our second one in July. Lots of fast-moving developments in this space. Check out some of those because a lot of what we cover is certainly still relevant today. So we'll share URLs for those in the chat as well. And note that we've got several AI-related podcasts for you to check out as well. We'll share some of those URLs. I don't want to distract you too much from the show that's happening right now, so don't go crazy on those links. Karan and Sasha, over to you guys.
Thanks, Chris, for running this series and curating all this information. Before I dive into talking to Sasha, I wanted to do a little plug for the institution that has brought Sasha and me together. So we are both faculty at Cornell Tech, which is Cornell University's technology and business focused campus in New York City. And we are strange colleagues in a way because I am an economist, operations professor by training, and Sasha is a computer science faculty by training. And in most other institutions, we would potentially be faculty in the same university, but we'd probably sit a few miles away. And it might as well be a few thousand miles away in terms of the interaction that typically happens. Universities tend to be very denominational and not have too much interaction across these boundaries. But at Cornell Tech, we've tried to create an institution where business faculty, computer science faculty, and other faculty who think about societal impact sit under one roof. And we're almost forced to have lunch together. We're forced to read each other's research. And today what you will see is really what is a typical lunch conversation at Cornell Tech, where an economist or a person from the business world is talking to someone in the computer science world. And Sasha is not just someone from the computer science world. He's one of our leading researchers in the area of what people are calling generative AI now, long before it was called generative AI or long before it was cool. So he's one of the original folks in this domain. Very excited to have Sasha and share the kind of conversations we have at Cornell Tech with our audience today. So today our topic, or what we want to talk about, is going to be open source in the context of large language models, or broadly generative AI. And the interesting thing about open source is it's one aspect of AI that has everyone excited, from the developers to the folks trying to build companies or finding applications for these models to the regulators. Everybody thinks of open source as a solution to a lot of the challenges. And so everybody talks about it. That said, I think it's quite nuanced. So today, Sasha will help us dive through that nuance, understand what is really new here, and how does that matter from a business and a technology point of view. So Sasha, let me start the conversation by simply asking you, what is open source? What does open source typically mean in this context or other contexts?
Yeah, thanks for having me, Karan. So I would say open source has kind of technical formal definitions, but intuitively people think of it as mostly free software that you have access to the internals of. And kind of famous examples like Linux are these kind of collaboratively developed open projects that originally were kind of done in kind of small teams, but are now kind of the thing powering a lot of compute around the world. The reason some of these questions are subtle is because a lot of it tends to kind of revolve around the licensing behind the software itself and what you're allowed to do with it. And so open source can mean a lot of different things within that context, but often it depends on kind of whether companies are able to use it, whether people are able to scale with it, and kind of how it's actually developed in practice. And there's a kind of wide range of different software projects that kind of fall under different open source guidelines.
So if I think about it, there is potentially three axes here. free, how much you pay for it, what's going on internally, and what you can do with it. That's kind of the three axes one could probably think about in open source. Now let's come to the context of large language models. In this context, I think what does open source really mean? Yeah, in the context of large language models.
So one thing that's crazy is that no one really knows right now. We're in a really wild frontier, and people are kind of in the process of coming up with these definitions and kind of formalizing it. But for most people, that matters less than what it actually means in terms of a community and what's being built. I think when people talk about it informally, they're really talking about the fact that large companies and small distributed organizations are training large language models or models for generative image processing and releasing it to the public. Now, that allows people to basically have access to things that are kind of getting close to the scale of OpenAI style generative models. And that's been really exciting to see what people are doing and building with them.
Yeah.
Now, the reason I say the definition is a little bit complicated is because, well, the main models that we think of as the kind of leaders in this kind of quote open source generative AI are models like the Llama model from Facebook, which under traditional definitions would really not be considered open source. They really just consist of a kind of single file that has a bunch of kind of mysterious values that we call weights that allow you to generate text. And so in that sense, the source is kind of not available. But because you're able to do interesting things with this, and because you're able to kind of build new and kind of variant models, people are kind of thinking of it within this realm of an open source kind of thing. And in fact, Facebook is kind of explicitly using the term open source AI.
Let me try to understand that a little better from a business point of view. So three aspects with that: how much you pay for using it, how much you know about the internals, and then what you can do with it. So I guess if OpenAI also has a free version, and as does Llama has a free version. And for those who might not know, OpenAI, we're talking about the company that is behind the GPT class of models, powering your Chat GPT, also powering some image generation models like DALL-E. So I think free, many versions are available free. And I guess what I'm hearing from you, it is the internals where this is how much you know about the internals or how much of the internals are open is where the distinction really is. So what are the typical internals in a large language model? What are different components in a large language model?
Yeah. So that's a good way of thinking about it. So OpenAI now has a kind of free tier where you're able to send a request to their headquarters. They'll process that request, run their secret large language model, and send you back the answer. So I think no one really considers that kind of within the realm of being open source. And despite the name of the company, people are thinking about that just as kind of a free to use kind of access to the model. Where Llama gets a little more interesting is that they're releasing what are called the weights of the model. So it's hard to describe what this is. It's kind of a big opaque file that they kind of post on the internet. And if you download this file, you can get it to basically speak to you. You can send it some text and it will return some new text. Now, in that sense, it's kind of similar to being able to basically run on your computer the thing that you would run on OpenAI's server.
Mm-hmm.
Where things start to get a little bit more interesting is you can do this secondary process, which people call fine-tuning, where you start with the weights of the model that you were given, and then you feed in some more data. Maybe this data is proprietary or even private, and you basically update the weights of the model to now take in this new data. It's hard to do that with these fully closed systems without sending them the private data or kind of paying them to update the weights for you. There's also another thing you can do with these models that people are excited about, which is that you can use them to generate more data at a very large scale, which allows you to do other things like train your own new models on that data. Again, this is something you may be able to do with some of the closed systems, But oftentimes the licensing of whether that's allowed or not is complex. And it's also complex for some of the open models, but it's a little bit more lenient.
Right. So I think what you can do with these models is great, but to still kind of, and we'll come back to that, but to really understand what are the internals that we can see. So if I go back to my 25 years back, I was a Linux hacker, and the good news about Linux was you could download the source and you could recompile it and you could create it from scratch. I don't think we can do that with the weights. So what gives here? This is not like I really have. So to really create this whole thing from scratch, what all would I need, and what all are different companies giving me? From what I understand, OpenAI is giving me nothing. They're like, you give us the data, and we'll process it for you. But Llama is giving us something, but it doesn't sound like what Linux gives me, that I can replicate it from start. So what's the difference here?
Yeah, so the secret sauce of something like Linux is the source code. It's the literal programming that people did all over the world to make Linux work. And that source code required lots of talent, lots of patches, and gets updated day to day. The source code for language models is actually not that complex. And in fact, roughly the similar source code can run all the different models you might know. The secret sauce of language models is the data they're trained on. And that data comes in two forms. One form is what's known as the pre-training data. And that's the data that these companies scrape from the entire web. So this is kind of every article, every book that's available on the web, all sorts of different texts from newspapers or from creative writing or from math or science papers. That data is not released with the models. And for most of these models, we don't really know exactly what they were trained on or how you might go about replicating that data. The second form of data is what's called instruction tuning data. And this is the data that gets the language model to kind of be polite and do what you ask it to do. So that's the data that gets ChatGPT to respond to your question, to produce good answers, to basically figure out what you're asking and come up with a good answer to it. That data is often produced by very large teams of people who are annotating and responding to questions. So they basically have kind of a massive factory of people who kind of give human answers to questions so that the model can learn from. That data is also not released with these systems, and it can be quite expensive to produce because you have to kind of pay folks to produce this data in this form. Now, because of that, it's not possible to, say, compile a language model by yourself because you don't have access to the data that you need to basically replicate this process. People think that the reason the kind of first data is not released is because of all the legal issues surrounding language models. Even if that data is accessible, it might not be legal to train on, and it's unclear whether it's allowed to be released with these models.
Right. And so OpenAI can pay its lawyers to fight against New York Times, but I might not be able to. So probably better for me not to even try messing with that data, and maybe for OpenAI not to kind of put that pre-training data out.
Well, that's one part of it, but the second part of it is at the moment, actually, we don't know what, say, Facebook is training on. They might not want to reveal that they trained on certain types of data. Again, it's just speculation, but we don't have a good sense.
Yeah, yeah. So and instruction data is costly to get. So companies spend a lot of money paying contractors, I imagine, around the world to annotate or to kind of really say this is a good response to a question. This is a polite way of talking. This is not a polite way of talking. So the source is simple. I heard, and you can tell me if I'm correct or incorrect here. Somebody told me the source for a large language model, roughly speaking, is under 1,000 lines of code. Is that a myth, or is that really truly true?
Yeah, it's a little bit subtle. So the code to run the language model once it's been trained is under 1,000 lines, and
The
you can
inference
read it.
stuff.
It's surprisingly readable. In fact, about 5 or 6 years ago, I wrote a blog post that goes through all of the different details of how these things work, and honestly, the code hasn't changed so much even in that time. Now, the code to train the model is a bit more complex. I mean, it's a lot more complex. It's not Linux style complex, but it can be a bit more challenging. But you don't actually need that to run the model in practice.
Right, right. So the training code is more complex than the inference code. So we have the source code, we have the data, but then it seems there's also, I would imagine, again, I'm no expert, but to train these on these very large corpuses of data, one probably has to come up with some tricks to make all the H100s work together in unison. So what about that piece? What do we call that, and how important is that?
Yeah, it's a good question. So we call this like distributed training. This refers to the fact that in order to train a model, you often need to use, say, hundreds of computers. And actually for Llama 3, I believe the number was that they used 16,000 H100s to train it. These things are extraordinarily expensive. The estimate for training Llama 3 was around $100 million for these computers. And so every millisecond counts when training them. So there are kind of world's experts on getting the most out of NVIDIA GPUs, world's experts on networking and data center construction and even energy in order to kind of make these things as efficient as possible. So in some sense, even if they open source that code, very, very few organizations in the world would be able to kind of take advantage of it or run it in their way. And in fact, I think Google is an interesting case study too. They basically use their own chips internally that you can use through the cloud, but they aren't actually released. So even if they kind of put out all the details there, basically it would only apply to them.
Right. And you think this stuff matters, right? So I'm calling maybe that is the engineering pipeline. There is the source code, there is the data, and I imagine there is all the things you mentioned, which are probably not necessarily the things that are getting the most attention, but are probably equally important: the networking, the efficiency, even the design of the computers and the data centers to run this. And none of that information is out there. So I see there are two problems. Even if the information was out there, I'd probably not have the money or the access to the chips to do it. And in some cases, those chips are really private. But the engineering of that is also not public or out there. Is that correct to say? Or some of that is more out in the open?
Yeah, that's correct to say. I mean, there's a lot of secrets about the details of these models and how they're trained. That being said, I think that people in the kind of open source community would be happy kind of just to know, say, the details of the data. There's kind of an assumption that perhaps the actual training of these systems may be beyond the reach of open source consortiums or things of that form, but that knowing what the models were trained on would be very helpful to know how things work. So I'll give you one example. One thing that's been very challenging with open source language models is that we don't fully know how to evaluate them or determine which one is better than another. And people are thinking very hard about kind of new benchmarks or new data sets to make this happen. But one question that comes up a lot is kind of data contamination. So because we do not know what these models are trained on, it makes it a little hard to know when they're doing something completely novel or whether they've kind of learned something from the data they were trained on. So even just kind of knowing what was or was not fed into the model would be beneficial for understanding the abilities they have or the kind of science behind how they work.
Very nice. Yeah, so I guess the next question would be on the what you can do with these models. So we know on the internals, we don't really know. It's not like Linux where you really know all the internals. We know some stuff which is not that hard to know, the source code or that innovative. The data is where the secret sauce might be, which we have limited information on, even in the most open models. And then the engineering skill, which would be another one to have, but I think data is the place where we want to start first. So at least we can evaluate and not get shocked next time ChatGPT says something that we think it is having emergent properties, but it might really be in the data. So at least that kind of shock, or people getting worried about their Terminator fantasies, would we could check that with knowing what the data might be. So that's cool. But what can we do with these models? I guess that's what, if I read what Mark Zuckerberg talks about open, he's using the word open source, but it's really not the source data which is open or the engineering which is open. But he says you can do a lot of new stuff with it that you couldn't do with other things. So what are the new things we can do with it, with these models? You mentioned one, we can run it locally. Beyond that, what else can we do, and why do we even care about running it locally? So yeah.
Yeah. So there's a bunch of things you can do with these models. And they all depend kind of how much compute or how much data you want to inject into the systems themselves. So the most common one that people talk about is this idea of fine tuning. So what's exciting about fine tuning is that, let's say, I don't know, I'm Bloomberg and I have a ton of interesting financial data, and I don't think that that data was originally used by the models to learn. I can take that data and continually train one of these open source models on that data. And even just giving it more data within a given domain will make it much better or much smarter in that setting. You can kind of do this with closed models, but you end up having to pay them a lot of money, and you don't have full control of the process, and maybe you have to kind of literally send them the data that you want to train on. So there's a lot of excitement. Oh, sorry, go on.
Yeah, question on fine tuning. What's the verdict on fine tuning? Because I hear some conflicting kind of research. One, and particularly in financial data, and Bloomberg's kind of model, which was fine tuned with their as good as it gets kind of proprietary financial data. Um, so the two streams I hear is, one, fine tuning will make these models better because they'll know a little bit more about the domain. And then the second stream I hear is, if we just increase the pre-training data, doesn't kind of matter. And even if you fine tune models, it's not like they necessarily adhere to the fine tuning data more than the pre-training data. So I don't know, what is the latest research on that? What is the practical kind of what is our best knowledge on fine tuning? Is it good, necessary, or mixed outcomes out of it?
There are a lot of small details about how this can work or how it can't work. A lot of it has to do with what's the most financially viable way to do it. So, for instance, it seems like a lot of times it's better to use a bigger model that was trained on more data than it is to, say, fine-tune a model. Um, but if you keep other things equal, fine-tuning is certainly going to improve the model within its space. And there's a general sense that we're maybe getting to the limit of, say, size of models or amount of training data. And so particularly having specialized data will be a kind of very useful thing going forward to get marginal gains.
And one more kind of understanding questions: fine tuning versus rags, or kind of in prompt, adding relevant information in the prompt. What's the verdict on, because I guess, and why it relates to open source. I think most systems will allow you to do some sort of retrieval augmented generation. Fine tuning is certainly much more complicated. So if one of the advantages of open source is more control on fine tuning, how relevant is that? Could I just get away with doing retrieval augmented generation instead?
Yeah, so let's define these terms just because people may not fully have a good sense of them. So generally in the research community, we think of two ways to get your model to learn about a new domain. One is fine tuning, where you actually change the weights of the system itself. The other is what's known as in-context learning, where you give it the examples you want it to learn from in its context. So you basically can think of the first as kind of changing its brain, and the second as kind of first telling it what you want it to know, and then asking it to produce responses. The difference between these two is a major question of research and one that people are still thinking a lot about. Practically at the moment, though, we know the following. We know that in-context learning is inherently limited in the sense that we can only make the context a certain length. So models have a fixed context length, and it's actually not extremely large. So think about it as maybe 10 pages that you can give to the model before running. The other downside of this is that when you do in context learning, you're making the approach slower. So you're going to have to pay for the extra cost of running this. So at the moment, we don't totally know which one works better, but we do know that fine-tuning can scale to much larger data, and therefore it's a useful tool in our current toolbox. Now, there's a third idea here, which is called RAG, Retrieval Augmented Generation. And the idea of that is that maybe you can't fit all your data in context, but you can fit a subset of your data within context that basically fits. And the way you do that is you use a much weaker model to first determine what subset you think will be important for every given query. This idea has been very practical for the last couple of years of using large language models. And certainly if I were, say, building a company today, that would be the first attempt that I would do. This works both for open source models and also for closed source models as a way of getting these models to work. That being said, in the long term, I think people think of this as maybe a band-aid and maybe not the kind of final attempt. We either expect to have extremely long in-context learning or figuring out really efficient ways to do fine-tuning. Which we end up will matter about whether open source or closed source wins and basically what the compute profiles look like.
Yeah, very nice. So, okay. So we can bring our own data in any of these formats, either fine-tuning, in-context learning, or retrieval augmented generation into models, and open source has some ease or advantage or control in doing that. What else can we do from open source models? What else can I do from Llama that I can't do from OpenAI's models?
Yeah. So one idea that's emerged as a kind of practical way of using open source models is this idea of distillation. So the term distillation in the machine learning literature means basically when you use a very smart model as the teacher and a very fast model as the student. And we actually do use those terminologies. And the hope is that if you can basically get a very, very, very expensive model to produce lots of good examples, you can teach a much smaller, faster student model to do those tasks. So the idea here is that you could take a really, really good model, but one that might be too expensive to run in production, and use it to basically generate a new data set for training a much smaller, faster model.
Yeah.
Now, in theory, technically you can do this with closed source approaches. You could just make lots of queries to OpenAI and train on those. Now, the legality of this is a little bit in question right now. There are certain aspects of their terms of service that maybe prevent this, but people have been doing it, and I think there are kind of cases ongoing. For the open models, people are explicitly writing licenses about this question of data distillation. So NVIDIA put out a very large model a couple weeks ago that allows you the freedom to basically distill it to any model you'd want. Llama also allows you to do this. They have some terminology about kind of the naming of the models you produce, but people are kind of understanding that this is maybe a practical use case that open models allow you to kind of work with.
This is fascinating because if I understand correctly, essentially the ChatGPT is overkill for the vast majority of tasks we need to do. Even and Apple in its strategy kind of acknowledges that. And right now we have this super smart kind of model for everything, and which is latency, cost, all of these challenges in production or in the inference stage when people are using them. But if we could use this to create specialized chat GPTs who don't know everything about the world, but for example, know everything. I can think of our use cases in our teaching. We're experimenting with using language models for, let's say, tutoring or other kind of Q&A type tasks that a teaching assistant would do. Probably a lot of that can be done with a much smaller model. And so the idea here would be to use a large model to create something very specific for us. What are the kind of cost benefits we can see by doing that if any of these things have been fully put in practice? Are we talking 1/10 the kind of runtime cost, inference cost, or smaller gains than that?
Yeah, I think it's not unreasonable that you could see something like 1/10 the cost. Again, particularly if you're doing a specialized model. One exciting one that Google actually recently released was a model known as Gemma 2B. And 2B refers to the fact that the model, the size of the kind of weights of the model is 2 billion parameters. Up until this point, people really hadn't been able to train very good models at that scale, but they were able to do it by training a much larger model and then distilling it to a smaller model that you could use in practice. Another one that
So just to benchmark that, so a normal model would be 400B or 400 billion, and we really, thanks to distillation, we could use that and perhaps create a 2 billion model. So that looks like a 200 times kind of reduction from a layman's kind of way in terms of the number of weights in there or number of parameters, which could be a 200 times reduction in cost if I had to do the back. Maybe not as good, but it sounds like almost as good.
Yeah, I think you should think of it more like 10 times. I don't think it's going to be as good as that scale. Um, as a rule of thumb, you can roughly think of these numbers as being the speed of these models. Again, it depends on whether you're trying to do a chatbot that's real time versus a model that's maybe offline. But I think roughly thinking about the size as the speed is not a bad a way of doing it. Um, One other thing to note, though, is that OpenAI has also been doing this. Well, I guess we don't know explicitly, but people assume they've been doing this as well. So ChatGPT hasn't been standing still. If you use the newest version, which I think they call ChatGPT 4.0 Mini, that's likely a distilled version of their much larger model that they're serving.
From a business point of view, I think distillation, again, I think beyond the cost and latency advantages, it's almost better if a model is not too general purpose. I almost like if a model knows only about my teaching and doesn't know about politics, for example, and therefore has almost no risk of bringing it in. So I don't know if that kind of control can happen, but I can see the let's say lobotomized or a scaled down version of the brain from a cost and latency point of view. Maybe it has advantages from keeping it on topic kind of point of view also. Or is that just speculation that may or may not happen?
I think it's an interesting idea. I should say that we are really at the kind of frontier of understanding how we can control what language models say or do. It's remained an extraordinarily hard challenge to do what's called unlearning, which is to get a model to forget something that it's produced. And I think that distillation by itself is not really a silver bullet for that. There are approaches that might help or that might be related to distillation, but we don't really have the technology to really kind of closely and very carefully put a guardrail around what a language model will talk about or do. And yeah, I can see why that would be a frustrating thing from a business perspective.
There's still plenty of good news here. From a business point of view, I think I can. What I'm seeing is I have perhaps not everything to recreate, but that is great for research, replicability, maybe not that useful from a practical point of view. From a practical point of view, I can get these open source models, run them any which way I like on my hardware, in my premises, add my own data with no risks of that data being touched by any other company. And potentially I could use it to train a very custom model for my particular business line, which will be faster, cheaper, and offer all the advantages that come of the responsiveness, etc., that come from that. Perhaps even completely new kinds of use cases, because we can kind of get these small models to work better. But there's one unanswered question. We often say you get what you pay for. So is the free stuff as good as the gold standard kind of, or the OpenAI stuff? How good is it? Are we compromising something on? I know it's hard to measure the performance of these models, but given the metrics people have been using, how close are we on the open side?
Yeah. One thing that's crazy about all this is how fast it's been moving. We're roughly like, I don't know, year and a half into some of these approaches. And we can say within the last couple weeks that we're pretty close. So it seems like the latest versions of Llama 3 that were released are nearing about where GPT-4 was when it was released on many of these benchmarks. I think a lot of people thought that was maybe not possible a couple of years ago, but it took about a year of time, but it seems like the open models have caught up. Now, we don't know what OpenAI is working on. They may now be prepping GPT-5, which may have all sorts of new things that will take open source a while to catch up on. But given how short a time frame it is, it's pretty impressive that they've reached that ability.
Yeah. So if I was a business executive, in your considered opinion, is it a dangerous thing to bet on open source, or I think it's a fair bet to, what would you do? You'd hedge your bets, and let's say you're thinking of a relatively high business value application where costs probably don't matter as much or matter less. Yeah. So what would you do in those cases? Hedge your bets, or you'd feel comfortable going one approach? I know it's a tough question to answer, and that's why neither of us are CIOs. But what would you recommend a CIO does in this kind of situation?
Yeah, I'm very underqualified for this question. That's one part about Cornell Tech that's interesting, is that you get behind your students and their understanding of business structure. But no, there are many advantages for open source. Not being locked into a vendor, being able to say choose other companies to actually run the inference of your model, being able to customize all these properties and be able to do it in a legal way. Depending on what your structure is, you may or may not be able to use certain open source models, and you have to take that into account. But it definitely seems like a viable path forward in a way that maybe it wasn't a year ago.
Very nice. Yeah, you mentioned lock-in. So lock-in is something that when if I start putting my business hat on, my economist hat on, when I first learned about pre-training or the structure of these models, I remember in the room, the computer scientists are, of course, excited about the performance of how good these models can do. But I was sitting there thinking of the cost structure, and I'm outing myself as a real dork, or a person who thinks about money a little more than perhaps I should. And to me, it seemed like the cost structure of pre-trained models was such that you'd have a lot of kind of fixed cost upfront to do this pre-training stage, and the fine-tuning would be a minor cost. And whenever we see that pattern of costs, when you create something generic at an expensive cost, and then you can create, a lot of people can in a way use it at relatively small customization costs, so to say, you tend to get winner take all markets because somebody makes that big thing in there. So my original prediction here and was that this is going to be like everything else big tech does, where the bigger gets better, and so somebody will invest a lot of money and then control the, so to say, the highway which everybody would have to use. I always think of them as infrastructure which has a similar cost structure. Got to pay a lot to lay down a road, and then everybody can use it with relatively modest costs. So my prediction was that it was going to become completely that it would have a winner take all nature, and somebody would become a monopoly. And as we've seen in other tech monopolies, everybody who builds any application that uses, for example, a language generation task for conversation, for code, anybody will have to use the same highway because it's the biggest and the only highway available. And we'd have to end up paying 30-40% of our returns, or maybe even a larger fraction of whatever we make through that, to that monopolist who controls the back end. I'm happy to say it hasn't worked out so far as that. But yeah, so what is your kind of, does that make sense, that thinking that these things have a tendency necessarily to go winner take all, and they're not yet becoming winner take all? Or I'm just yeah, what do you think about that?
It's an interesting question. There are a couple aspects that have been quite interesting, which is we've seen a lot of smaller companies that were pre-training models kind of stop as the costs continued to get higher. In that sense, it seemed like, as you were saying, things were kind of congealing into a kind of winner take all scenario. The people who are still doing it are places like Meta that seem to have alternative reasons for trying to avoid vendor lock-in. And in his letter about Llama 3, Mark Zuckerberg explicitly talks about the fact that he felt so burned by the kind of tax that Apple took on its apps, that he felt it was necessary to kind of at any cost avoid that. Now, we'll see if that continues. I mean, as each generation of these models seems to be exponentially more expensive, he'll have to keep on kind of paying to keep on doing this.
So it's more like a battle of the monopolists or battle of the aspiring monopolists, where one might just want to play a spoiler to not let anyone else be a monopolist, rather than it becoming necessarily kind of where you and I can compete. But how do companies like, and we haven't really mentioned the big players here, but I imagine the big open source model would be Llama. Mistral is also a company which has what I believe is mostly open model. How are any insights on how are they able to pull it off, or it's just people do a lot of things in the early ages of technology advancement?
Mistral is an extremely impressive company. They've been able to get a lot of really strong engineering talent working there, and they've been able to produce some really strong open models. The history of it was that the founders of Mistral, or some of them, were from the original Llama team, so kind of forked off of that project. But they've been able to hire a lot of great folks interested in both open model building and other aspects. Their models are only partially open source, so they have kind of lower tier models that are extremely good, that are open. And then they have some larger models that are either not open or open with licenses that restrict usage over a certain size. That being said, they're an extremely impressive company, and they've been able to keep up with a lot of what's going on. Yeah, no, I really hope to see them kind of continue growing over the next couple of years.
Yeah. I think we have a few questions now. I think we have time to perhaps take one question from Elizabeth. We do these live, unlike a podcast, so we can truly interact with folks. So Elizabeth's question, perhaps Chris, you can tell us more about what Elizabeth wanted to ask.
Yeah, let me chime in. So Elizabeth asks, do you have to worry about divulging trade secrets if you use Llama 3 or others? What are some of the IP issues for companies when they use open source models? She goes further. In other words, what do companies need to worry about in protecting their proprietary data if they use these systems?
Yeah, so if you are running Llama 3 on your own hardware or on your own cloud, it's not going to be shipping kind of any data off premises. The weights that Facebook provides are fully just a file that you can run. It's not a system or a code, and it doesn't have any kind of security risk of that form. A lot of people are running these open source models with third-party inference providers. So these are companies that have done the work to set up the infrastructure to run these systems extremely fast. If you are sending your data to these parties, you have to kind of be careful about their terms or how they're managing the data themselves. I know there are some that can set it up to run it within your cloud or within your infrastructure, but others simply just kind of literally take your data and send you the response of the models. And in that case, you should treat it like any other data being shipped off.
So overall, it looks like a promising kind of development. I always like saying that I was somewhat pessimistic about how this large language model, or broadly the new generative AI technology, was evolving. It seemed like something which would be another tech monopoly where the big players have the advantage. And while that does remain true, but I think the big players are working very hard, it seems, to make this accessible, make this as accessible and as easy to build with as you could. Now, I've not seen that in any previous generation of technology. And like I always like saying, these models are easy to build with, but it is much harder to know what to build and what not to build with them. So that's almost in a way, the technologists have done their job, that they've made something quite accessible. And in the specific case of open source, what I learned today was these models are essentially do what you want with them, by and large free. Now, they're not telling us everything about what the secret sauce to train it, but at some level, unless you're trying to compete with them in the model layer, that doesn't matter. From the user application layer, most of the things you'd want to do, use these models to, for example, as Elizabeth was asking, really you can inject your data much more safely without really worrying about any leakage at any place in the pipeline. If you're a regulated business, everything is within your control, within your standard IT practices. So it gives you a lot more ability to deal with that. And then this brilliant idea of distillation, which is you can use these models as teachers to create smaller student models, which is essentially, if we think about it, that's how we train employees, that's how we train agents in every situation, which is possible with these open source models, not so much possible with other models. So they're free. You can do less risks and more things you can do with them, and at least for now, as good in performance. So this seemed like a big win here. Thank you so much, Sasha, for highlighting these advantages of open source models. I know our students are always ahead, and people, CIOs, and other folks who are struggling with these choices are always ahead. But I think we can say that there is a new option that folks should very seriously consider because of the advantages we mentioned, as they think about building their internal AI stacks.
Perfect. Good. I want to chime in. I want to thank both our host, Karan, and our guest, Sasha, for your insights on today's rapidly developing story, open source and AI. I want to thank our viewers, of course, as well. We cannot do this without you. So I'm hoping that you'll actually take a moment to let us know how we're doing. I need your feedback. Please be honest. Here comes the QR code. So give us some ratings and feedback. Let us know how we're doing. And a reminder that the recording of this event that you're watching right now will be available shortly at the same URL in just a matter of minutes. So Sasha, Karan, thanks to you too, and thank to our viewers. I hope you see you all in future keynotes. Heads up for the next episode of AI Today, soon to publish. So we'll talk to you soon. Thanks, guys. Great to have you.